Okay, this is one of the lucky times when you don't have to motivate your topic. Presumably here everyone's interested in microfinance. So I'll just tell you what the paper's about right away. So what do? The first thing we do, we're going to develop, the paper does is develops a buffer stock savings model where people save for precautionary reasons. This is a very well-known model. We add in the simple twist that there's a lumpy investment, that you can save in liquid savings, which pays a low yield, or you can have an indivisible lumpy investment that you can make, some sort of a project that has a high yield. We're going to estimate the model using data, and then this is using tie data. There's a large-scale quasi-experimental. It's not a randomized experiment, but it has random elements to it. We're going to use this policy to evaluate the model. So I write down the model, estimate it with using data before the experiment, then see what the model predicts for the experiment, and compare that to what actually happens in the data. So this is a way of evaluating the model, evaluating the theory of household behavior under credit constraints. The second thing we do is the model does, fails in some dimensions, does well in some dimensions, but it does reasonably well enough that I think we can take the model seriously. So then use the model to go back and evaluate the policy. So the policy is used to sort of test, evaluate the model, and then later the model is used to evaluate the policy. So let me give you, whenever you have a conference, you're never sure how far you're going to get. So I'll give you the results right away, a preview of the results. So the program is setting up microfinance institutions in villages in Thailand to expand lending. The program increased consumption more than 1-for-1 with credit. So this is kind of big impacts on consumption. For every dollar of credit you inject in, you get more than that of an increase in consumption. And the effects on investment are a little bit harder to discern, but especially in another paper we have, we think they're there. The model is going to fail statistically. So every statistical test you run in this model is going to tell you that our model is not the real world. We're not that disheartened by that, because it's still going to be able to, in terms of predicting the effects of this policy, it does reasonably well. And I guess that's all we're maybe shooting for many models, to be able to get some predictive power. And then when we use the model to evaluate microfinance, microfinance is going to be cost effective, and it's going to cost 2/3 as much as if you wanted to have a transfer program that gave equivalent benefits. That program would cost 50% more than the microfinance program. Okay, so there's a cost savings in terms of microfinance. Let me give you a little description of what this policy intervention is. It's a Thai million baht village fund program. Not sure if anybody's familiar with it. To my knowledge, it's the biggest government microfinance intervention in the world. In 2001, when it was instituted, they spent 1.5% of GDP. So this is a massive undertaking of a government program. So ISA has some quasi-experimental elements to it. The first is it was very much of a surprise. Parliament was dissolved in November 2000, and then new, now former Prime Minister Thaksin Shinawatra, who was ousted in a coup earlier last year, was elected 3 months later, and he was to some extent a political outsider. It's a little bit like Ross Perot in the U.S. He was the wealthiest businessman in Thailand and came in on a populist platform. So part of his platform was this million baht village fund program. But the fact that it was sudden is this program was not anticipated. Okay? So there's a suddenness to this. The second thing is what they did was they gave 1 million baht to every single village in Thailand. So nearly 80,000. But each village received the same amount of money regardless of how big they were. Okay? So if you were in a small village, you got a lot of money. So one of our villages is 33 households. That's a lot of money for each household. It actually ended up being, on a per capita basis, 40% of their annual income. This is a big transfer. If you were in a big village, a couple thousand people, you know, you didn't see any of this money, so it didn't really matter to you, okay? So what we're going to use is sort of this village size as an instrument. And it's not just the size of the village, it's the incremental effect of village size after the introduction of the program, which is really the instrument that we're using, although we're going to use structural methods. So all of the villages in our data receive the money in the same year. Okay, so this is an idea of how much predictive power village size has. On the x-axis is the inverse number of households in the village. So this is the village with 33 households. This is a village with a couple thousand households. Okay, and so you can see that the small villages got a lot of money per capita, and the large villages got very little. It's triangular shape to the data. So that's one aspect of an instrument. The other aspect that I'd have to show you is that village size isn't correlated with any of the outcome measures. I'm not going to show you that, but we have another paper that documents it very well. So, so we're pretty confident of this instrument. Here's an actual regression of village size on how much credit you got. And this, this coefficient here is 760,000. So that's when we go back and ask the institutions how much did you lend out. That's precisely they say 800,000 or something. But that's virtually what they lent out. Okay, so this is really predicting. Village size really predicts how much credit households got. So what are these funds? They're quasi-formal micro-lending villages. What does quasi-formal mean? So there's actually no building. It's a group of villagers got together. They form a committee. They process loans. You have to apply for loans. They keep books and this sort of thing. But it's somewhere between a club and an institution. Okay. Typical loan would be 20,000 baht. That's $500 exchange rate. Terms for 1 year, 2 guarantors, and very low interest rates, 6% nominal interest rates. Now, inflation in Thailand is very, very low, so that ends up being about 5% real interest rate, but nonetheless, that's a very low interest rate relative to most microfinance loans. I'll get back to that at some point here. So here's a model. The first thing is your value. This is your lifetime utility. You maximize the expected value of lifetime utility by choosing a stream of consumption, a stream of savings, which can go negative, you can borrow. This is your liquid savings. And decisions on whether or not to invest. And what is the state? How do households differ? Well, they have different amounts of starting liquidity. They have different starting projects. This is the size of a project that you might invest in. And they have different permanent income. And S lower bar is going to be the crucial parameter in the model. So the first constraint that they face is that consumption plus liquid savings plus their investment, and this is, again, they get a project size, and they can either decide to invest or not to invest. You can't buy half of a tractor. You have to either buy the tractor or not. Okay? That has to be less than their available liquidity. The second constraint is that this is the borrowing constraint. This says that your liquid savings, you can imagine S bar being negative, it can go negative, but you can't borrow any more than a certain fraction of your permanent income. Okay? So S bar is going to be a parameter that indicates how much you're able to borrow. So this is a particular type of credit constraint where you're going to face a very low interest rate and then an infinite interest rate. You just simply can't borrow after a certain amount. So in practice, if you have to go to a money lender, interest rates are infinite, but they're pretty close to that. So we're going to ignore the role of informal lenders here and just look at basically a formal market. Well, informal meaning, you know, from a money lender or something like that. Family loans will all be included in this. So you have your expenditures have to be less than your liquidity. Your savings is bounded below. You can't borrow too much. then what happens to your permanent income? Your permanent income tomorrow is a function of your permanent income today times, this is the permanent component of your income, times a drift, so there might just be exogenous growth in income, and you have a shock that your permanent income can take a shock any period. So this is exogenous changes in your permanent income over time, and this is endogenous. You can have a higher permanent income tomorrow if you make your investment, okay, and your investment pays a yield which is, big R. Savings is going to pay a small yield, small interest rate, and investment is going to pay a higher yield, but it's going to be illiquid and indivisible. Okay, so this tells you what the return on savings is. Your total liquidity is your income this year, plus your savings, plus interest that you got on your savings last year. That's all your available liquidity, okay? And your income, this income is your permanent income, which is right here, times your transitory income, okay? So what's going on? People face permanent income shocks, they face transitory income shocks, they face investment opportunities. And they have to try to, because they can't, their credit is constrained, if they would like to invest in the high yield, illiquid project, okay? But the high yield illiquid project doesn't help them if they have a bad shock. So they're also going to keep some savings as a precaution against adverse shocks. Okay? So the three shocks in the model, the stochastic elements in the model that we're going to have to estimate the processes for is the permanent income shock, the transitory income shock, and investment opportunities. Now, your investment, the size of your project is a function of your permanent income. If you're a person with high income, you invest in larger projects, okay? And the opportunities that come your way are larger. So this means that wealthy people are still constrained in their investment opportunities. And this is consistent with the data that you see. The reason we do this lumpy project size is that in the data, maybe 1 out of 6 years, we have 7 years of data, maybe 1 out of 7 years of data does a household invest in. When they do invest, it's a substantial amount of their income. So you don't see people always investing a small amount. You see them investing very infrequently, and when they do, it's a lot. And when you compare rich and poor households, you see that rich households invest a little bit more, but they're still only investing 1 out of every 4 years in the data. So this lumpiness of investment plays a big role. That you can't. If investment weren't lumpy, and you have an investment that pays a higher yield, I pays a higher yield than S, then you should always be investing a little bit of this into this high yield project. And we don't see that, so we think that people can't buy half a tractor, like I said.
So your agents see that.
What's it?
Your agents see that.
Oh, they know that.
Okay, they know this. You just.
Yeah, that's right. So this is what happens. We assume that all these shocks are IID. It's a pretty grand assumption. We're going to make a lot of grand assumptions here. Okay. Permanent income follows a random walk. The exogenous part of it. Log normal distribution for that. Log normal distribution for the transitory income shocks. We're going to have to estimate the variances of those. And we're going to have to estimate what the average project size is that people face and what the variance of project sizes are, okay? So people that don't invest are going to be people who typically have a project that they can't afford to invest in. Okay? Everybody always has a project every year. So the way we've written the model, let me go back here, it's possible that you borrowed so much money. I'll go to this one. It's possible that you borrowed so much money last year, okay? And you had a bad shock to your permanent income and maybe a bad shock to your transitory income, that next year the total amount of liquidity you have is simply not enough to pay off your loans, okay? So you have to default. So you can imagine that when you get a low permanent income shock, the bank says, we don't want to lend you as much this year, okay? So this is kind of like a margin call on a stock, where you have to come up with the money to pay back your stocks when the value of your stocks goes down. Okay, so we have to think about default, because there's times when people simply can't pay back. So what do we do for default? Well, this little c, in the end, if you default, you get there's some fraction of your permanent income that's guaranteed consumption that the bank can't seize. You take the rest of your money, you give it to the bank, you say, okay, we're even, I don't owe you anything. The bank renegotiates, they say, we'll take whatever you have. And you can't invest. The bank's not going to allow you to invest if you're defaulting. One thing you can see here is that default probability, if I borrowed to invest last period, so the reason this is negative is because I invested, well, that's going to increase my permanent income. So it increases this side, okay? So it's much less likely that I default if I borrowed to invest than if I borrowed to consume. If I borrowed to consume, this didn't go up because of the loan, okay? So this just tells you what happens. The consumption is a constant fraction of your permanent income. Savings goes down to the bare minimum. So I owe the bank. So if the bank is willing to lend me $5,000, that's what we renegotiate to. That's what I owe them, and they take the rest of my money, and they tell me that I can't invest. So, see how am I doing on time? Half an hour. Okay, so I'll go through. The way this is written up, this is technical, but the way the problem is written up, you can simplify this a lot because we have a three-state problem where you have to keep track of liquidity, project size, and permanent income. But this problem is homogeneous in permanent income, so you can divide everything by permanent income. And really what you have to keep track of for each individual is how much liquidity they have relative to their permanent income and how big the project size is relative to their permanent income. Okay? So you only have to keep track of the ratios. So instead of keeping track of 3 things, we really have to keep track of 2 states, and it simplifies may not seem like it simplifies it, but it simplifies the model and the computation tremendously. So from now on, all these lowercase letters are all ratios of liquidity to permanent income, consumption to permanent income, and investment to permanent income. And P prime is permanent income tomorrow relative to permanent income today, so that's your permanent income growth. Okay? So here this shows that when you invest, permanent income growth goes up. So the first order condition, this is the Euler equation. It tells you optimization in terms of consumption today versus consumption tomorrow. It tells you this is the marginal utility of consumption today, the value of consumption today, and this is the expected value of, instead of consuming, saving the dollar, getting the interest, and consuming tomorrow, you have to discount utility tomorrow. And what this basically says is that if the household is constrained, and this is a multiplier on the borrowing constraint, if the household is borrowed as much as it can, okay, then this is positive, which says that today the marginal utility of consumption is a lot higher than it will be tomorrow. Okay, that means I'm really needy for liquidity today. So higher marginal utility of consumption today than tomorrow when I have borrowing limit. So every extra dollar that I get, I'm going to spend on consumption today, okay, if I'm borrowing constrained. So anybody who's up against their constraint looks like a hand-to-mouth consumer. If I give you any extra money, any extra liquidity, you're just going to consume it, okay? Every dollar you make, you consume. Every extra dollar you make, you consume. This is a picture of the value function for the model. Still doing fine. So what's here? This is your value function. This is your expected lifetime utility. This here is the project size. So if you have the value utility depends on the project that you have today. And this is your liquidity to permanent income ratio. Okay? And this line here is a break between 2 value functions. Over in this region, you're not investing. You don't have enough money to invest. And over here, you are investing. you're going to wait to invest. If you have a very small project, you'll invest when you have a little bit of liquidity. When you have enough liquidity, you'll invest. If it's a very big project, you're going to wait till you have a lot of money before you invest, because once you put the money in, it's illiquid, and you can't get at it, and you face risks. You face income risks. Okay? So this line here is a kink in the value function when we're really taking the maximum of two value functions. What does it say? This says right here, once you've invested, you have a high marginal utility of a little bit of additional income. Why is that? Well, take a slice of the policy function. So for a given project, a guy who has a given project, this tells you how much they consume as a function of their permanent income. Okay? Now, when they have very low, as a function of their liquidity, when they have very low liquidity, they're hand-to-mouth consumers. So this line is a 45-degree angle. Just says, I consume all the liquidity that I have, all the available liquidity that I have. Okay? As my available liquidity gets higher and higher, then eventually I start saving a little bit. Now, the difference between this red line and this black line is basically savings. So these people, they'd like to be borrowing, but they can't. So they're not investing, but they're constrained. These people are not investing, but they're unconstrained in the sense that they're not spending all of their money. They're saving some, or they're not borrowing as much as they could be. Okay? But after a while, if I have enough money in the bank account, I say, why do I have all this money in the bank account making 1% interest? I could invest in a project that gets a much higher yield. Okay? So imagine you have $1,000 in the bank account, or you have a project that costs $1,000 that you want to invest in. You want to buy a piece of agricultural equipment or something. You don't wait until you have $1,000 to buy it because it's so high yield that you'd wait until you have $800 maybe in the bank. You buy it and you borrow the rest of it from your consumption. You just live a little, on a tighter budget for a little while. So here's what happens is when you decide to invest, at the lowest liquidity that you decide to invest, your consumption actually goes down. This is what my wife and I did when we bought a house. We had to make a down payment, and things were pretty tight for a while. Our consumption went down when we bought a house, and they really motivated the model. Then afterwards, every extra dollar you get, you consume. And then finally, so these people in this range are investing, but because they're investing, they're constrained. Okay? And they're consumption constrained. And these people are investing, but they have enough liquidity that not only can they make their investment, but they also have some money in the bank. Does everybody follow that? So one question is this empirically relevant, this idea that consumption would actually drop when you invest? Because this only happens because this project size is lumpy. So there's a pretty well-known paper by Zeldez where he tested for credit constraints. And what he did was he looked at consumption growth. And he said if the consumption growth from today to tomorrow it is related to your income today, if you're credit constrained, that means if you have low income, you have low consumption today, but on average you'll have higher consumption tomorrow. So people with low income have high consumption growth. People with high income today have lower consumption growth. And that's what he found. He found that this beta 2 was negative, and so that was evidence of a credit constraint. We run the same regression, put investment in. We find that if you have high income, the same thing is true. I mean, if you have low income, the same thing is true. You're more likely to be constrained if you have low income, to have high consumption growth, but you're also more likely to have high consumption growth if you invest. So people that are investing are more likely to be constrained using this Zeldez approach. So we think this is empirically relevant. Given this indivisible project size, this model has impacts which are both heterogeneous across household. They depend, if I give you money, a little bit of money or not depends on how much permanent income you have, how much liquidity you have, how big your project is. So they're heterogeneous. They're also nonlinear. If you're really close to being able to invest, I can give you a little bit of money and it has a big impact. If you're not credit constrained at all and I give you a little bit of money, it doesn't have much of an impact at all. Okay? So the impacts are both heterogeneous and nonlinear. And the other thing is that you can imagine there's multiple outcome measures. You might try to evaluate this by running some regressions on, say, investment. How does investment respond to the credit? How does consumption respond to the credit, or to the program? And how does credit respond to the introduction of the program? So I'm going to show you three households, three theoretical households. They're identical and they're observables. So they each, and what's observable? Well, you don't observe permanent income, and you don't observe the project size. You only observe a person's project size if they get to invest in it. You never know what people might have invested in if they could have. Okay? So what do you observe? You observe their income and their liquidity. The first household decides to his credit goes up, his consumption goes down, and his investment goes up. Okay? The second household, credit goes up, consumption goes up, so in the opposite direction as the first household, and their investment doesn't change. Oh, I should mention, all of these three households, by the way, are going to benefit from the program. Okay? So they're going to look very different in their responses, but they'll each benefit from the program. So the third household doesn't even borrow, okay? But still benefits from the program, and you see that his consumption goes up, and we'll say that his investment stays the same, okay? What's going on here? They differ in their unobservables, okay? The first household has a very low permanent income. So they have the exact same actual income. So for the first household, this was a very good year, okay? So if you give him a little bit of or her a little bit of money, they're able to make their investment, okay? This is probably better explained going to a picture, which shows you what, did everybody understand the figure that I showed? I'll show you another thing. Okay, so here are the three households. Household one is the one that decides to invest if you give them a little bit of extra money. So if you give them access to $100, it puts them over this cliff here. Oh, I should tell you what this graph is. This is their consumption. So this is a 3D picture of the one I just showed you. So this cliff is when their consumption drops because they decide to invest. Okay? So this again is the project size. This is their liquidity. And this is their consumption to permanent income. Okay? So it's upward sloping for the most part, but there is a point where your consumption drops, and this is precisely the point where you decide to make this investment and borrow from your today's consumption. Okay? This first household, you give them a little bit of money, he's going to make the investment, his consumption goes down. Second household differs in terms of their liquidity. They had a higher permanent income. So for the second household, this was a bad year of your income. These guys both made the same income. This person was a good year for, this person was a bad year for. I'm sorry, this person was a good year for, this person was a bad year for. So this guy usually makes a lot of money. This year he didn't make much money. And he's constrained. He would like to be borrowing. Okay? So if you give him a little bit of money, he's not going to spend it on investment. He's going to spend it on consumption. Okay? This third person has a small project, and it was a good year for this person too. Okay? So it was a good year, and they actually had a small project. They were able to make the investment even if you didn't have the microfinance. Okay? What's going to happen? So this person has a consumption drop. This person has their consumption grow. This person's already saving. They don't even want to borrow this year. But their consumption goes up. And this is crucial. Why does their consumption go up? Because they know in the future that they can borrow if things go wrong from the microfinance institution. So even if I don't borrow today, the fact that I'll be able to borrow in the future tells me I don't need this buffer stock. I don't need to store as much rice as I've been storing. I don't need to have as much money under my mattress or in a savings account. All of these sort of low yield, inefficient ways that people save, they say, well, I can consume a little bit of that today. So their consumption goes up. So even the people that don't borrow, potentially their consumption goes up, but this depends a lot on, you run a regression, and some of these people's consumption is going down, some of these people's consumption is going up, these things cancel out, and you might interpret that as saying it didn't have any effect on consumption. Well, in fact, it had very important effects on consumption, and it had very important effects on utility, if you believe this model, that you won't be able to discern so easily from just a linear regression. Okay? Again, I want you to remember these third households, the guys who consume, whose consumption goes up without borrowing, because they're going to be crucial in interpreting some of the results. This is a crazy graph that my co-author made me put in, which is explaining the same thing. You know, this is the household. The red line is before the microfinance institution. The black line is after. I'll just skip this. I explained it in words. I hope everybody understood what's going on. So what's our empirical approach? Okay, the first thing is we're going to estimate the parameters in the model using a two-stage GMM, only on the pre-experimental data. So only using the before data, we estimate the parameters. And then we're going to think about the million bot program as being a surprise decrease in this borrowing constraint. So all of a sudden you can borrow more than you could before. What are we going to do? We're going to run astructural regressions, so linear regressions that are typically run on the actual data and on the simulated data that our model produces, and say, I mean, in this part, I'm going to tell you the model is completely rejected. In this part, we're going to say, okay, the model's completely rejected, but does it look like what the actual data looks like? Could you distinguish between our model and the real world using the standard techniques that people use? The answer is going to be no. And then we're going to measure the welfare benefit using the structural model and compare it to the program costs, basically. So the first stage GMM, how do we estimate this? What are the moments? Basically, we're going to choose, we have to choose the variance of transitory income shocks, the variance of permanent income shocks, the drift, the interest rate on liquid savings, and this combination of how much you can consume and how much your minimum consumption and your borrowing. We do it in two stages because this, computationally, you don't have to solve the policy function for this. And the moments that we match are that drift matches average income growth. This is basically how we identify this stuff. Transitory income shocks show up as short-term volatility in income growth. Permanent income shocks show up as long-term volatility in income growth. This just matches the interest rate on savings and loans that we see in the data. And this we identify by looking at the default probability. And I showed you the equation for that before. That's the first stage. The second stage, we have to actually solve this model. It's very time-consuming to do. We actually need to use a supercomputer to do that, but that's probably less of a function of the modeling, more on my program writing ability. We have to estimate the process for these project sizes, the average project size and the variance of project sizes, the utility parameters, and the borrowing constraint. So this is a structural model, but every parameter in this model is something that has some either obvious economic meaning or is something that people are used to thinking about. Intertemporal elasticity of substitution, discount rate, a borrowing constraint. Okay? What do? We pick the moments to match average log consumption in the data, the probability of investing in the data, and the average log investment size in the data. And we want to not only match it for the entire sample, but we want to match it for people of all different types of, we don't want to say rich people we're overestimating for, poor people we're underestimating for, but on average we're correct. Ideally, we'd like to get the rich people correct, poor people correct, people with high liquidity correct, the people with low liquidity correct. So in the end, we end up having tons of moments because the deviations here are supposed to be orthogonal to liquidity and income levels. Here's an example of a moment. We take actual consumption in the data minus predicted consumption and try to set that equal to 0 and set the correlations with log income and with liquidity to income ratios, set those equal to 0. What's the data we use? We have 7 years of panel data, 5 years before, 2 years after. 720 households in the panel data across 64 villages. We are the only people with a before and after panel data set, and we have the data that we need. And I'll skip over this. We have to adjust the data to get rid of predictable sources of variation. There are a lot of things that are not in the model. So we run regressions to get rid of differences in household composition. And also there's business cycle effects from year to year that aren't in the model. So we get rid of things that are correlated with the exchange rate. We use this adjusted data to feed directly into the model. Here are the estimates. Just a couple things. There's a lot of income volatility in the data. These are basically standard parameters, the results you always get, for discounting, intertemporal elasticity substitutions in a regular range. It says very little exogenous growth without investment and a very low interest rate. Okay? This is the volatility in project sizes. It's much bigger than what you actually see in terms of investment. But that's because when people get very big projects, they can't invest. Okay? So the projects that people realize are much larger and much more volatile than what you observe on average, because it's only the small projects that people can afford to invest in. And finally, the borrowing constraint is that in the baseline, before the program, people can borrow 8% of their average income in a year. Okay? This is all for short-term borrowing. These J values tell you that there's no way that this model is the real world. Okay, so statistically, this thing is horribly rejected. We've got 10 parameters that are trying to hit 60 moments. Okay, so you can imagine trying to do 60 things with 10 parameters is pretty tough, and that's what that's telling us. Again, we don't think that's a reason to throw the model out. We'll see how well it does in predicting the data. So the next thing we have to do is calibrate the borrowing constraint. So we have to say, how much does a million baht program hit the borrowing constraint? Now for each village, we choose a new borrowing constraint such that on average our model would predict that you're borrowing a million baht per person, a million baht per village, more than you would have with the previous borrowing constraint. Okay? So if you're in a big village, S-bar moves very little before and after the program. If you're in a small village, it moves a lot. So in the biggest village, it goes from 0.08 to being able to borrow 15%. In the smallest village, these guys are able to borrow 170% of their average income for a year. So these are big differences. Okay. Now we test the model. How do we do this? That's a data sets. It's supposed to say data sets. We create 1,000 data sets from the model, just picking random draws on these U, N, and I, and we run regressions. And we run the regression on both the actual and the simulated data. We look at an outcome variable, either investment, decision to invest, or the probability of investment, and consumption. Throw in a fixed effect. Throw in the two states, which are observable states, which are income and liquidity. And this is sort of our measure of the effect of the program, which is after the program is instituted, what's the effect? This is 1 million divided by the number of households in the village is the average credit injection per household. Okay, so what this is going to do is measure average. Now this is a nonlinear thing, so you're fitting a linear function to this, and people are moving in different directions. But this is going to measure average increase in, for example, consumption from an extra $1 of credit per household. Okay, and we're going to compare the results of the simulated model with the actual model. So this is embarrassing because it's too close in some sense. You guys think I probably cooked the data. I tried to run it again, take new draws, and maybe get something a little bit off. But the top part here is the actual data. And when I said consumption responds more than 1-for-1 with investment. So this is 1.07 is the standard error. It's significant. On average, the model is predicting the exact same thing. Okay, it's almost the exact same numbers. All right. So it's predicting a big increase in consumption. When we originally presented these results, my co-author did in Thailand, were very upset about this. They said this is evidence that people just blew the money, and in fact they spent more than what they were given. and an increase in consumption. We think that one of the big benefits is that these programs help you to smooth consumption. But the reason this is bigger than one in the model, I don't know if the model is the same explanation in the data, but in the model it's because people no longer have to have these big buffer stocks anymore to insure themselves. So they gradually spend this down. This is also sort of a smoking gun about these people being credit constrained. Because even if this program had an income effect, imagine you just say, we're going to give you $1 million baht. You never have to pay it back at all. That's the biggest income effect you could possibly have. A model where people aren't credit constrained would say you should smooth your consumption over time. You don't increase your consumption in the first year by even 1 for 1, much less more than 1 for 1. So the buffer stock model provides an explanation for why you'd see these big increases in consumption. It also provides an explanation for why we don't see increases in investment. The reason we don't see increases in investment is because, well, think of this one here. This is actually a negative sign on investment. On average, we're giving people $500, okay? So you have to be a person that's really close to being able to invest in order for that to matter for your investment decision. There are some people who are going to invest anyway, okay? And there are some people that can't invest even if you give them $500. And it's overall investment is not driven by people making $500 or $1,000 investments. It's by one person building a structure or something, which is a factory, which is much larger than microfinance loans. So microfinance investments are hard to tease out in average data. We also don't see a big effect in investment probability though. So it's not even the size of the loans, but also just the investment probability. It's because these guys are only investing 1 out of 7 years. So the model predicts that you should go from investing from a 0.07 times, probability of investing is 0.07 to the probability of investing of 0.1. So that's just a 3% increase in the probability of investing. And in our data sample we have, it's just not large enough to pick that up on average. So the fact that investments are highly volatile, which we estimate in the data, drives these results. But we can look at the model and say that what the model predicts is that on average this should have substantial impacts on investment, although they're hard to see. So 30% of investment should increase by 30% by this program. Okay. So let's do the cost-benefit analysis. I think I'm still okay on time.
We have about 3 minutes.
3 minutes.
Well,
Okay, so I'm almost done. So what do? We say, what's the value of having the $1 million baht borrowing constraint in expectation? Compare that to the value of having your old borrowing constraint, but getting a transfer, okay? And then you add up the cost of the transfer, compare it to the cost of the $1 million baht fund per household. On average, the $1 million baht transfer is 1/3 less than the cost of the $1 million baht program costs 1/3 less than the transfer, and still less for small transfers. Why is this the case? It's because the $1 million baht program is lowering the borrowing constraint for people. Okay? When you give transfers to money, you give money equally. When you give the $1 million baht program to people, you give money to people that want to borrow. Those are the people that have the highest value for their of increases in liquidity. So to the extent that the microfinance program increases intermediation, it's giving money to the right people rather than just distributing it equally. Okay? You can see here the results, which is that small increases are much more cost effective than large increases. So small increases, just giving the people access to 5,000 bahts per household means a lot, because these are the guys. Initially, these guys are really constrained, and as they move up this, they're less and less constrained. So the benefits become less and less to giving additional money. Okay, so this is telling something about the limitations of microfinance, to the extent that a lot of the gains from microfinance are from consumption smoothly. We do one more thing. People might be disconcerted that it didn't have a big effect on investment. So we say, well, what if the microfinance program were set up such that you have to invest in order to borrow? So the only time you get a lower borrowing constraint is if you're investing. Money's still fungible, so it's not clear that you're borrowing to invest. You might have invested before anyway, but we can at least see what effects this has. And the results the model predicts is that you get more small investment, still doesn't show up in aggregate investment, but you do get a higher probability of investing and a smaller impact on consumption, and that this program is marginally more cost effective than the one that was actually instituted. So conclusions, bold conclusions, but that's how it is. So first is credit constraints are real and important. We think this model is a smoking gun, that credit constraints are important for these people. And Thailand's an example of a country with pretty good financial services to rural people, but credit constraints still show up as important. Not only that, but this buffer stock savings model is sort of plausible explanation for what we see in the data. The structural model assists with the interpretation a great deal, and the model predicts that microfinance is cost effective.
Thank you. So we have time for questions from the floor. I'll let you choose.
Hi. At the time or right after this program and the money was handed over to the households, was the government making any active measures to push investment avenues in front of villagers? You could do this, you could do that, number one. And number two, when you talk about investments, are they mostly agriculture related, like a little well, some water boring device, mainly agriculture related, or can you just a little bit about the nature of projects that people would invest in?
This includes both business investment and agricultural investment. What we see in terms of investments, I told you that investments increased. This model, you couldn't see it. When I throw in fixed effects for households, actually the number for investments becomes significant for agricultural investment. It doesn't become significant for business investments. So we didn't see, we have business investments in the data, we didn't see an impact on business investments. These are mainly rural villages. So the other thing was the government pushing? The government pushes a lot. Another program that Takshin started was this thing called One Tambon, One Product, which is almost like a centrally planning type of idea, but it's mainly a marketing thing where they wanted to have each village specialize in producing some sort of local good and selling it. We don't see that that's really happening very much. But that being said, that's the impact of the program. We do see business investments in these villages, and it's just not clear that the program increased business investments, but it may have made households much better off in that the households were going to make these business investments, and the program just makes it a little bit easier on their budget to do this. I don't know if that answers the question.
Actually, what I was wondering is that the land tenure arrangement in Thailand then would have had some impact on the way people actually ended up using the money that they got. If they were mainly agricultural, if the bulk of the investment is in agriculture-related activities, so then the land tenure system would have some impact, right? You have incentive to invest in, say, a little thing on your land if you own that, rather than if you're just a worker on somebody else's.
Yeah. Thailand is, most people own land in Thailand.
Okay.
Question is whether or not you can, whether or not you have a title for that land affects how much you can borrow, but people do own their land. So in terms of incentives, long-run incentives, I think that those aren't a big issue.
Have you tried to parameterize a little bit more your structural equations? For example, the discount factor, you could use the observed individual characteristics as a linear function of your discount factor, for example.
Yeah.
I understand that it's very costly numerically, but I think in that way perhaps you can then do your final regressions where you compare the data with the simulations from the model, and you can include all these other households observed characteristics. Because that's going to give you more weight to compare those parameters.
So we do a little bit more of an ad hoc. I mean, so the first thing is those regressions do include household characteristics, but they're done in an astructural way, not in a structural way.
But the ones that you simulate from the model do not account for that.
No, this was the thing I had to go back. I went quickly over. So here's the regression equation. Here's a regression equation. So it doesn't look like there's any household characteristics outside of the income and the liquidity in that, right? But what we do here is we adjust all this data. We take out the household observed characteristics and the business cycle characteristics out of the data. So you can think of these as being, the regressions are already differencing out this thing. So you can imagine these as just being controls in those regressions. That's the equivalent. In terms of the regression, that's equivalent. In terms of the estimation of the parameters, I guess it has a different effect, the structurals.
Yeah, I mean, I thought.
But I would love to be able to do this in the purest of the pure ways, but it's really computationally impossible.
And I mean, this is pretty similar to what Todd and Hopin do, right? So with the Progressa example, kind of similar, right? But I was wondering if you can somehow discretize your state space and kind of add more variables so that you fit better the data, or is just that impossible?
No, I mean, okay, so I don't want to upset counterpatron, but in principle, we're very similar. We're trying to test the structural model, how it can predict. I would rather err on the side that I err on than in the side that I think they err on, which is they add a lot of heterogeneity. And so they're going to pass a lot more statistical tests. You add a lot more parameters to a model. It becomes a lot easier to fit data. On the other hand, you also lose a lot of the transparency of what's going on. So I think their model has something like 140 parameters, okay? And so you just have no idea what these parameters are doing. I guess I would rather err on the side of, at least I can explain, I think people know what's going on, and you're going to say the model misses statistically. And, I guess that's fine. In some ways, you can't distinguish between curve fitting and, once you add tons of parameters, it may not be a structural model in the sense that the parameters you're adding we may not have any reason to believe that they're deep parameters. They may just be ad hoc parameters for fitting the data. So I think this is a way of doing that where it's transparently ad hoc. I mean, it's ad hoc.
I'm just wondering about investment opportunities in larger villages. That's why people consume rather than invest.
Yeah.
How large the investment opportunities in those larger villages?
So obviously in the model, we say that investment opportunities are constant across villages, but village size is used as an instrument. So you might say, are you wondering whether we're confounding the effects of the program with investment opportunities?
Right.
Yeah. So in the other paper that I mentioned, we look at, does village size, is it related to investment, for example, before the onset of the program? Now we have 5 years of before data, only 2 years of after data. The 5 years of before data, we see no relationship between village size and the probability of investing, or even average investment size. So we think that this is probably an exogenous thing, and it doesn't matter whether you put in whether you do this in differences or levels, what kind of controls you put in. It's pretty robust. So we're pretty confident of it. Because it's not just village size, it's incrementally. Once you put in the program, does village size have a bigger effect?
I wonder if you were concerned that your 5 years of before data were during the financial crisis, and so the year that you're starting with, right, you're still looking at low levels of capacity utilization in Thai manufacturing, and you're looking at low levels of credit because the banks were still sort of struggling under that. And whether that may be part of why you're seeing low levels of investment and higher levels of consumption is more because of the after effects of the financial crisis.
So the first thing is, the financial crisis is definitely causing these problems. So the way we took care of it was putting in these exchange rate variables and lags, and that doesn't take care of it. So one of the reasons that the model was rejected strongly statistically is because, you know, year to year, I'm not trying to predict it on average for the whole sample, I'm trying to predict it right every single year. And there's movements that this doesn't do well in controlling for. So certainly that's a problem. That's one of the reasons when we run these regressions, that we put in these time-specific fixed effects. So this isn't a time trend that we're picking up, because time-specific fixed effects are already in there. So this could be a difference in time-specific time trends across large and small villages, but it can't be an average difference. It has to be something that turns once the program comes in, because even if I do this in differences, village size isn't so important. So the answer is there are some secular things that are going on in the data, but I don't think that they're affecting our results strongly. Yeah.
Well, first thing, this is a really nice paper. I think pushes out the point here. I wanted to come back to this sort of that last result on when you sort of compared the actual, you sort of evaluated things, and you looked at how investments sort of stayed flat and consumption went up. And one of the mechanisms you seem to keep on referring to is sort of consumption's going up even full households, just because they don't have to worry about that buffer stock anymore.
Yeah.
So, do you have any data on buffer stock investment?
So direct evidence on buffer stock. The first is, it's hard to get direct evidence on the buffer stock ratio because your permanent income is unobserved. But we do have evidence that assets are going down. So both savings and other types of assets are being depleted. So
And I was just going to say, I mean, part of what you might be measuring as investment might be you're investing less in buffer stock accumulation, right? There's really two types of investment.
oh, that's right. This is like it's like a portfolio asset allocation problem within your portfolio. I mean, in principle, what you'd like to do is get the stuff out of the low yield liquid return and get it into the high yield, high yield illiquid return. But once you get in the high yield illiquid return, your income in the future goes up, which is another effect. And if you're able to borrow, you'd like to borrow today. You don't want your consumption path to follow such a steep profile if you're able to borrow. So that's exactly the results we found, and we have another paper with A-structure regressions, and these are the results we found. And I told you when my co-author presented this stuff in Thailand. You know, I think without this model in mind, it's hard to think about of what's going on. So that's one of the, I think, the benefits of having a structural model. Yep.
Basically, imagine I wanted to. I'm trying to think on the intuition of investing projects of different sizes. Like if somebody has very low liquidity constraints, so you're in the very high end of liquidity. In more than what the model says, if I have if the projects keep the same, they have the same quality, right? They have an R or a return that is fixed. Is that true?
Yeah.
How am I going to choose between let's say three small projects or one big project?
Yeah.
If choosing among those two options give me the same return or they can provide the same quality. So in a way, isn't the stochastic component of the project size linked to the liquidity distribution because of these?
Yeah. No, I mean, I think you're, in the real world, I think you're definitely right. In some ways, this in the A-structure results, I talk about an asset allocation. I mean, a portfolio allocation problem between two assets. But in reality, people probably face a lot of potential assets they could. You might have some people that if you give them a little bit of money, they'll start a business. But if they start a business, that means they can't send their kid to school. And maybe there's somebody else who says, I get a little bit of money, I'll be able to send my kid to school, but only if I sell my business. Imagine these two guys, in the same way we have this thing going between consumption and investment, you run a regression, these guys cancel out. So I think these things are actually very important, but way too complicated. I mean, the first model, you should start writing a simple model and then building up. I always try writing a model that seems the most reasonable to me, and then say, cut out the reasonableness in order to be able to solve it. So I couldn't solve the model where you had a bunch of different projects. But I think that's got to be important. That's right. So in some ways, this assumption about this exogenous project size is bad. But the way we test the model, I think it does well enough relative to the data that I'm confident it's not too bad. But maybe I'm wrong.
Do you think that the money that this program will give you have to have an investment project to get the money from the microfinance program?
That is not how the program works now. That was a counterfactual policy. Where you say, what if they decided to have this rule that you have to invest in order to borrow?
So you didn't observe more investment after the program, or you observe more investment after?
Are you asking about in the real world or in the model?
In the real world.
In the real world, it's hard to discern investment. In the other paper, we do get positive increases, positive and significant increases in the probability of making small investments and agricultural investments. But we have to clean the data to get rid of all the big investments that drive, average investment is determined by if some guy builds a house or a factory. If it just happens to be that the guy built a factory in a big village or a medium-sized village, that's going to throw out the results completely. So the fact that these project sizes are extremely skewed, it makes it hard to discern. So you have to clean the data in order to get effects on investment.
About this government-sponsored program, whether the villagers get money, expect that maybe they don't have to repay the money later, and that's why they increase their consumption because no much investment effect from your estimate.
Yeah. So this. Oh no, I don't have the. Yes, I.
The last two tables.
No, I didn't put it in. Okay, forget. Oh yes, I did. Okay. So there's definitely heterogeneity. Let me tell you what the government did. They came in and said they have a carrot and a stick. The carrot is if you guys do well, if your village does well with this program, after 3 years, if you're evaluated as successful, you can borrow at a reduced interest rate from the BAC. So you kind of leverage your assets. That's the carrot. The stick is, if you guys screw this program up, we're cutting you, you're going to go into autarky as far as the government is concerned. We're cutting you off from everything. I don't know that I'm positive they would actually want to do this, but the villagers seem to be, when we talk to them, they seem to have this in their mind. But still, there's a lot of heterogeneity. So this is the coefficient of credit on village side. One other thing, repayment rates are relatively high. They lent out the same amount in the first year as they did in the second year, and we have later data. So even 4 years out, repayment rates are relatively high in this. But there is a lot of those are average. There is a lot of heterogeneity. So village size is doing really well in predicting it. You're going to get this coefficient of 760,000 in the first year. Still very significant, but it drops off a lot to 580,000 in the second year. That doesn't mean that they lent less money, because when you look at these intercepts, the average intercept is much larger in the second year. All it means is that the amount of money they lent out in the second year is less correlated with village size. So there were some villages that were very successful and some villages that failed. In the first year, it was almost completely determined by village size. In the second year, some of it's village size and some of it's whether you lived in a village that did well operating this fund or not. So there is institutions that fail. Yeah.
Is it possible to consider the impact of the initial income distribution on the final outcome? That is, if initially more people are below the poverty line, then maybe they want to spend most of their extra money on consumption and food and basic stuff. instead of investment that you invest? Like maybe higher probability or below poverty line, and
Yeah.
maybe higher impact on
Yeah, so
consumption.
in principle, we could do that. So we have 15 households per village. So in terms of income distribution, we don't have a lot of data to estimate a poverty line for each village. I guess in principle, we could do that. We have a month.
I'm just wondering how sensitive are your results to the assumption that you made on the distributions of the shocks? Because you said that they are IID.
Yeah.
What if they follow a first order Markov process? Because maybe the shocks are created last year or whatever, last month. So
Yeah.
are the sequences gonna become better or?
I don't know. Income, for example, is not IID, right? Because even income changes are not IID because you have this permanent component and this random component. All we do is assume that those are IID. Like, I mean, the fact of the matter is these assumptions are really pretty grand assumptions. I think actually what I was much more worried about was the project size, that these things are IIT, which is kind of like, last year I could have invested in this, I didn't do it. Next year I might have to pay more for whatever I had to do or less for whatever I do. So that's really troubling, and I guess the other alternative we had in terms of something that was, feasible, was to just say that you get a project and it stays the same until you invest in it, and then after you invest in it, you draw another project. That model exists already to some extent, and it has similar dynamics in terms. Quantitatively, it's not going to be similar, but it has similar dynamics in terms of you dropping when you decide to invest, that sort of thing. Yeah, I mean, the only thing I can say is I'm making grand assumptions, and in some way we have a way of evaluating those assumptions. To the extent that leaving a lot of aspects of reality out makes me fail statistically, then there's maybe explanations for why the model is being rejected statistically. In terms of predicting the impact of the program, I guess there's kind of two ways you can think about it. One is we got really lucky. That may be, I don't know. The other is that maybe the simplifications that we made in the model weren't so important in terms of predicting these aggregate effects or something like
Okay, maybe one more.
that. Sorry.
Could it be that poor households are not uninvesting because not just because they're impatient with consumption, say because they want to consume right away, but also because they're impatient to see the results of the investment sooner, that would get them out from this predicament or some poverty they feel in. So could it be that, and I think this could be related to this lumpiness in projects that they take years or so to take on, because it could be that poor households don't have access to appropriate assets or these that would kind of work better for them.
Yeah. I mean, that's exactly it. I mean, so let me go real quick to this. This is the last question. The estimates. Let me clarify something. Okay, so the first thing is this beta, 0.961. This is the standard discount rate you get, for the U.S., for most, any country. So these guys don't appear to be particularly impatient. But what they appear to be is they have a really low return to savings. I mean, if you're saving rice, that's a negative return on savings, right? Some of it spoils. They have a low return on savings, and they also have, now the estimate is actually lower than the interest rate that I told you, which was something like 4 or 5% for borrowing, but they don't have a real high cost of borrowing either. So that's one of the reasons that they're willing to consume, it's not because, it doesn't seem to be because they're so impatient. But the fact of the matter is it's precisely the fact that this investment is illiquid and indivisible is the reason that they don't want to make the investment. If the investment paid the same return but was liquid, like savings, nobody would save rice or cash. They would all make these high yield, this high yield, high payoff, quick payoff return, because that's basically like liquid savings. So that's exactly what the problem is. That's right. And so this is what the microfinance institution, to the extent that it does increase savings, allows you to have access to liquidity when your investment is illiquid, to be able to make these illiquid